Welcome to this webinar in the series of webinars we're doing on transport. And this webinar will be optimizing transport planning to deliver a more efficient, profitable, sustainable transport industry. So the agenda, well, what we will show today is that optimizing transport planning is a comprehensive approach that leverages data, advanced analytics, and AI to create a transport system that is efficient, reliable, profitable, and sustainable, as I said. By integrating these elements, transport planners can address current challenges and prepare for future demands. Today, our speakers are myself, Michael Boyle. I'm head of sales at Anico, and joining me is Colm Hayden, CEO of Anico. Thank you, Colm. Let's just go back there. Thank you. I'll go to the next slide. So just one slide on who we are. I won't overlabor this. And if you've joined our previous ones, you'll have already seen this particular slide. But it's always a good reminder of who we are. We are a data engineering company, and we offer consulting, solution, and teams as a service. What we do is help customers and partners build and operate data and analytics platforms. We work heavily across transport, logistics, and supply chain, and we have built hundreds of platforms. We've worked specifically on optimizing transport in both public and private sectors, and this is exactly what Colm will be talking to today, and we'll be addressing the challenges that are seen in these sectors. Now, what's interesting is last month we presented, if you might recall, and if you didn't, please go to it on our blog, that we presented on AI around the transport sector, and we presented that webinar live from RTX. We were also at the multimodal event as well last month, and these were at the NEC in Birmingham, UK. Now, at that event, we met many transport planners, and they spoke about their challenges. So this is exactly why we're doing this webinar today, because we're addressing many of the questions that came from those people and how we were talking to them today. And I know I can see some of them have joined today, but we're still continuing to talk to those after that event, because the points and the pains they brought up are very real that we're all experiencing. So let's get into it. Optimizing transport planning involves using advanced methods and technologies to improve, as we've said, efficiency, reliability, profitability, and sustainability. These are words we see all over the transport and supply chain, but they have deep meaning inside there. And the goal is to make best use of the available resources, is to reduce costs, is to enhance service quality to our customers, and it's to minimize the environmental impact. But what we can do is break down into that, because sometimes that can be too 20,000 foot. And what we need to do is really start to say, well, what does it mean when we talk about efficiency? What we're going to be talking about, and what Colm's going to be addressing, is how do you improve the use of resources, vehicle, infrastructure, and personnel. And that's fundamentally to minimize waste and reduce travel times. Reliability is ensuring transport services operate consistently and according to the schedules that are put out. And of course, that's heavily in the public sector. But to meet the expectations of the users can also reflect heavily in the private sector as well. And we'll be addressing that. Profitability, to enhance revenue generation while reducing operational costs, is to really achieve financial sustainability. And then, of course, that brings us into sustainability, which is that very wide topic, which we saw so much at multimodal in particular, that's been addressed by so much across the sectors, is minimizing the environmental impact. Now, we all know in the UK, we're having to adhere to ESG, the environment, social and governance. And across Europe, or if you're impacted by Europe, here in Ireland, where both myself and Colm are speaking from, but also touching the Netherlands, France and Germany, places like this, you're looking more at CSRD. And so you are having to look at reducing emissions and having to report on that, and promoting the use of clean energy enhances your CSRD. So we can talk about these core 4 areas, but what does it mean in terms of, can I touch and feel what my benefits are really going to be for me as a business. Again, both in the public and private sector. And the answers are very real. There are very real, tangible benefits. When we look at enhanced operational efficiency, we can reduce travel times, we can decrease delays, we can utilize vehicles better, we can utilize the infrastructure better because of the data that's coming to us. In increased profitability, we can lower the operational costs through efficient resource management. We can increase revenue through improved service quality and reliability. Now, all of these, again, are going to be addressed of how does a company like an eco, which is focused on data, address these and bring these challenges to these tangible benefits. We can increase the user experience and CEX, the customer experience, which is, again, a really topical environment, just as it is with sustainability. And it's things like passenger satisfaction, because the buses and trains are coming on time when it said they were coming. Better information that's been reported to people so that they know where they are. If something's going to be late, nothing is better than being told it's going to be late, and then it arrives at that new time, and then immediately you get passenger satisfaction again. The environmental benefits are often massive and obvious, but are still the core focus on most businesses today because of ESG and CSRD. And this is all around reducing emissions and fuel consumption, the promotion of sustainable. So if you're being good in the sustainable world, you want to promote it so that your company has that USP over and above another company. And this is actually very important in terms of data reporting. And economic growth is not to be put to a side either, because all of this adds towards improving the transport infrastructure that supports all the other economic activities, and the enhanced connectivity facilitates trade and commerce in developing worlds as well as fully developed markets. So they were tangible, but is it quantifiable? Now, you can look through these stats yourself, the references of which will all be provided, and you can go off and look at all of these references, but all of these are global reports that have been produced, and some of them we've been very much connected with. But of all the ones I just spoke about, the very first one there I wanted to quote on purpose, because we didn't actually come to that one, which is safety. The reasons why you actually move down this path. Safety is actually first and foremost in most businesses today. And going through this process, a 15% reduction in traffic accidents has been seen. Emissions, 20% reduction in CO2. Now that alone, if all the businesses were adopting it, would solve most of the reporting credential requirements for CSRD and ESG. In operational, both 30% reduction in maintenance cost, 50% reduction has been reported in unplanned downtime, simply due to this, which Colin will be talking to in a moment. Scheduling, as we talked about, 20% improvement in on-time performance. Satisfaction, that CEX rating that we talked about, a 25% increase for passengers. Economic, 25% in cost saving, and things like congestion. And again, this then feeds back into emissions, particularly when you're in certain congestion zones, is a 30% reduction in traffic delays. And if your traffic delays are reduced, your emissions within that zone are concurrently reduced. So optimization stages, it's important to say that planning optimization, it's not new. We all do it, both in our private lives, and there have been transport planners around since as long as there's been transport. So we're not trying to say that when you look across these 4 key stages of you must get data, you must plan, you monitor it, and then you optimize. Well, that's not new. That's not new at all. We all do it. As I say, if you're planning your holiday, we would actually go through this process. You might write on a piece of paper, you might keep it in your head, but you would follow this. So what has changed to create some of the challenges that, as I say, the transport planners as we're talking about today? Well, what's changed is another big term we've seen for nearly the last decade now is digital transformation. What this has done is created a potentially more complex world. And as a result, the process of following through these 4 key stages is actually more daunting. It offers the advantages and benefits that we saw on the previous slide, but to get to those benefits can be quite challenging. Now, why is it so challenging? Because when we're talking about this type of this type of optimization, it is data driven. It all starts with data. It wasn't coincidence that data was number one on the left-hand side. It's if you don't start with the data, then the result you get at the end is almost meaningless. So you must start at data. And when it's data driven, you start looking at all of the different areas: traffic data with sensors, cameras, GPS, public data, passenger counts as people are getting on buses and trains. Environmental data, we have full access to weather data. We have air quality all around us now. Social data, we can access demographics and economic insights. And all of this can be pooled together with the infrastructure, the road networks, changing road networks, public transport as they change live. All of this is pooling together to create a vast volume of data that certainly also needs to be stored somewhere. And we look to the cloud, we look to AWS, we look to Microsoft Azure and Google to store all this into these data lakes. But we have to actually then get in there and disseminate that data and make it so it's readable, understandable, and verifiable and trusted so that you can work with it. And that's precisely what Colin will be talking about. So when you are looking to data-driven optimization, then you also create data-driven strategies. And these are predominantly the strategies that you work from the top down, very much on purpose. And you listening here today, whether it's online or on demand, may be at one of these stages. First stage is you must collect. You must also do what is very, very difficult, particularly when you're looking at disparate systems, is you must integrate, you must bring together data from all different sides of automated data captures, image recognitions from number plate recognition systems, things like this, but also natural language processing. So all of this is coming together to collect this data, as I say, into the data lakes. Then you must process it. And you must look at processing and analytics. When you're in this area, you may be already looking at demand forecasting. What do I need to be doing based on the history? Traffic prediction. Where is it yesterday? What is it looking like today? What is it probably going to look at next week on the same day at the same hour? Can I also look at anomalies? And that's why slowly you're working towards simulation and data processing, which ends up the very last one there, which is something we talked about last month, which is AI or ML. So, and we can go into the semantics between the difference between these two. Fundamentally, they are, of course, very, very similar. We tend to put them together, but they are different. The machine learning first, and then following on then with AI. And we'll be talking to that. We did in our last webinar, so please go back to have a look at that. But these stages are the stages that we work through when your strategy is now around data-driven. And it's at this stage I want to now hand over to Colin, who can walk through the real-life examples of how these are put into play. So, Colin, please, to you.
Yeah, thank you, Mike. So, hi, everyone. My name's Colin Hayden. I'm CEO and co-founder at Anico. And over 20 years at Anico, we've been delivering data and analytics projects. And I'm going to take the control of the slides, Mike. Hopefully I can share. Yep. And are you now seeing my slides?
Okay.
Yeah. So I'm going to talk through 3 different scenarios and use Mike's grouping of data, planning, monitoring, and optimization to give you a flavor of what's involved. So one of the projects we're working on is in optimizing rail transport. So rail planning optimization. And a key requirement in this, railway tracks don't change that often. They're long, very long, multi-year, 10-year plans. And so long-term planning is very much optimized for efficiency. When you're looking at the past and predicting into the future, you're trying to calculate what kind of trains and carriages do you need to meet the expected demand? What kind of tracks do you have what's the frequency of that service, and ultimately what staff and crew do you need to deliver that. And in the long-term planning, that's optimized for efficiency, for profitability, and increasingly those sustainability agendas that are very much aligned with the decarbonisation of the rail network. When then you think into the short term, so UK's 3 and 6 months timetables, they're optimized for events and external impact. So events are, you know, that there's a summer season, you know, that schools are changing, you might know of annual sporting events that have a particular factor. And there are external impacts that are coming more near term. So you kind of know whether there's temporary lane closures, track closures. And here in Belfast, we have the great investment against the new transport hub that will introduce new train services and introduce new train lines. And so there is a temporary impact during the construction that needs to be factored. And alternative services, sometimes not on rail, and a temporary bus service is used, and that needs to be factored in. And then in the real-time monitoring, there's a real switch around. So dispatchers look in the next 24 hours, really optimized for customer service. So events beyond your control, like flooding, like breakdowns, like something on the tracks, they can impact that delivery of the expected customer service, and you need to react quickly. And reacting quickly depends upon the availability of, a reactionary plan that's been in place, but also the availability of crew, the staff that manage the trains, and they're the drivers, the cleaners, the inspectors. And they each have their own timetables that are impacted by their own availability, planned and on-time planned leave, and constraints, what hours they can work, and very much unionized rules to ensure that you're not asking somebody to work harder than they were employed to do. And this requires a huge amount of historic data, real-time data, and post-analysis of that. So from an infrastructure, you're looking at the rail network, the stations, the depots, the lines, and that infrastructure is broken down into segments, because each segment has a running speed, it has an elevation, so that can impact the efficiency and the speed of the train along that segment of the track. There's trips, ultimately defined by start and end destination. The rolling stock, the trains, the carriages, and what they would call sub-trains. So how you, using a process called shunting, reorganize 9 carriages to 6 carriages, because you're changing the service to meet a lower demand of passengers at that time of day. There's the crew, and you're not just looking at their competencies, what they're trained to drive, what they're, continual customer service improvement training they've received, but you need to in particular know their working patterns, shifts, and that's something that needs to be responded to very quickly when there's a need to dynamically reallocate people at shifts in a last minute to ensure everything goes on time, because it's dependent on somebody arriving at a train station for the job within 15 minutes of that train arriving sometimes. There's a train location, a train describer, and GPS might capture that. There's the running time. So what is the expected duration of time for a particular segment of the track? And then passenger loading. So passenger need and demand. You very often look back at history. You can make a general rule, but there is always trends that are changing. And the increasing introduction of digitized technology, digital tickets, and knowing your customer, your passenger better, allows you to better predict and respond to passenger loading. But still, there's a huge amount of analysis, and it's a very it's a very complex area, prime for data analysis. When you're looking at, you need to monitor and understand the delays. So why delays happened, how can we prevent them in future? You need to be aware of emergency services or spare services like bus services, and there's planned maintenance as well as unplanned maintenance. So an awful lot of data coming together, and that creates a timetable. There's an ideal timetable, and then you're planning resource against that. We need somebody with these skills trained to drive this train for this segment of the track, and they need to be available in these hours. And then there's the allocation of those resources, which then considers the more real-time availability of staff. So yes, we hoped a driver with those skills was available. There's been an unforeseen sickness, and we need to, find an alternative drivers for that service. So then when you're monitoring, the real-time monitoring, looking at the punctuality, the departures, as the competencies and training of the staff and the crew sufficient to meet what's there, or do you need to train more staff with a broader set of skills to give you greater flexibility? What's the real passenger loading? So we expected to have this many passengers, what in fact happened. Platform occupation, how long you're waiting on a platform, because that delay in that period in there, very often you say, we as passengers, on one side like to have a punctual train, on the other side don't like to see the train running off when we're running off the platform. And the condition of the assets and operational status. So there's a lot of monitoring data that's looking at real time from operational purposes and can be used for historic analysis afterwards. And that delay attribution, why did it get delayed? The running time, what was the actual running time? What were the shift swaps? And were there any cancellations of that service? So there's a huge amount of data involved in this. This comes from a wide area of services. This is kind of the examples that needs to be considered from a planning point of view. So if I move forwards, for some reason I'm sticking, there you go. In practice, what this means is we're, from a data perspective, identifying the strategic objectives, the key performance indicators, and some are shown there, from trusted sources, and setting targets, and then monitoring the actuals. So we're looking at the delays, we're looking at work and recorded, and then there's in the optimization, the analysis of those delays, the performance, the staff working patterns and preferences. And you can see how a huge amount of data across the whole network and infrastructure and passengers come together into forecast-based reports and planning, and then a daily analysis and a real-time view against them. When you look in an alternative public sector or passenger transport scenario, buses, one of the benefits of a bus is they're not against a fixed bus route. So when there's a road closure, the bus can make an alternative path. And that's very common, and the bus has to deal with congestion of other traffic because it isn't in control of that rail network. And so a very common technique in bus planning is to use peak vehicle requirements. So for this route, for this depot, for this service, how many vehicles do I need? And I need enough to service, as well as a spare amount that deal with that unforeseen breakdown. And when you look, there is an alternative technique that's more effective in rural bus transport optimization called demand responsive transport. And that's really where technology has enabled a shared mobility service. Instead of having predefined routes and timetables and stops, there's more on-demand services. But that has a key dependency on data communication and channel, and we'll see that start to emerge in areas in future. It is particularly effective where there's a low population over a wide area. So rural Northern Ireland, rural Scotland, ideal examples. But the data here is coming from the bus telematics, the maintenance schedules, the statistics recorded at each depot, and you'll always see on buses lots of inspectors taking notes and recording, and data. That's not just about tickets, that's about the service. And you need to look at the traffic, and be aware of how roadworks and planned activities can have a short-term impact. In looking at that peak vehicle requirements, the way we've seen it operate is to have by depot an expected number of peak vehicles in each depot and see, is that being met in the first instance, and is that appropriate in the second instance? So you're planning, you're looking at timetables, and from monitoring the punctuality, reliability. Why is a vehicle off road? So was there a planned PSV, or was there an unplanned maintenance? Did it break down? Was there a collision, an accident? And from the safety, as Mike described, optimizing for safety, you need to think of the passenger and the staff. So crime and injury is a real factor. When you're optimizing labor, there's a real difference between planned labor and overtime costs. So that's always an area that's from a financial perspective looked at. And in optimizing, really tuning that number of spare buses, getting ahead, understanding predictive maintenance. So the more you analyze what has happened in the past, and the more you can feed that. And bus manufacturers, like in Northern Ireland, Wrightbus, are increasingly providing highly sophisticated buses that can help with a predictive maintenance schedule. So they provide so much data, and they're so instrumented with telemetry that there's great analysis, and then the bus manufacturers are creating their own analytics to help the bus operator. You're looking at training and, again, passenger loading. So, that's again, huge volumes of data. And in practice, what this looks like is, Mike mentioned, we work in multiple cloud technologies. Happen to show here a Power BI example where data sources, we're pulling in live data and analyzing it, and we're comparing it and aggregating it with historic data and reporting that. So you're seeing on a daily schedule by depot, have you met or you failed to meet the peak vehicle requirement? You're looking at the punctuality and reliability experience and statistics on a weekly, monthly, and annual basis. And you're analyzing why a vehicle's off road. So is it waiting on parts, or are you waiting on labor to fix it? Now, if I go into a freight, so rather than delivering passengers and transport, we're talking about delivering freight. And Mike described our last webinar, well worth going back to, which was discussing a frictionless border. So how do you clear customs in international freight shipping? And in that shipping, the vehicles and the drivers and those long-term shipments can be streamlined with transport management systems and other tools. And an area that can deliver the greatest cost optimization and cost control as well is in the last mile delivery. So last mile delivery is the last step of the delivery process where a parcel is going from its hub to the final destination. So that's the parcel arriving at your door or perhaps being sent to a retail store. And from a consumer perspective, we expect fast, free shipping. So, whereas that's a very expensive part of the process because it's not a standard route. And so you need to consider the warehouses, the route data, how you can load many parcels into one delivery vehicle. You need to understand the packages themselves, their size, their weight, that enables you to consider the capacity. You need to understand the customer, and that's geospatial analysis. So Where are those customers based? What are the routes and roads to get to them? Do you have delivery hubs close enough to them? What's the time to do that? And where these individual distribution hubs can facilitate the intermodal shipping from one mode of delivery to the next. In that planning, the supply, demand, and very much as we see electric vehicles being introduced to last mile delivery, the range, we're considering the geospatial analysis and real-time monitorings, looking at the roadworks, the traffic. There's all kinds of data here to optimize those routes and provide custom analysis, as well as using a range of products that are available. So in practice, this might look like the Amazon cargo vehicle on the right that's been loaded with a set of parcels for a particular route. There's the analysis of where that's going. And from the optimization, some of the things that are looked at are order accuracy. Has that order been shipped to the right person at the right time? And that's very often measured by complaints per shipped order. The fuel consumption rate and the average service time. So how much time was spent fulfilling the order from picking up in the warehouse, completing the docks to proven delivery. Damage claims. Is there a claims because of a damaged good during shipment? And Mike and I met at Multimodal and had discussions subsequent with a company that puts advanced sensors on the shipped goods in order to detect tilt and impact. So a very expensive Xbox, for example, needs to be stacked in a certain way if it's been shipped for part of a delivery, but manhandling can cause that. And the cost of an unsatisfied customer not getting their delivery, but even worse, replacing a damaged good in that process is something that can be optimized. And looking at the mileage, so planned mileage to actual mileage, the cost per mile, are you using those vehicles correctly? Were there any unnecessary stoppages? So you can't control this, and even more so than the bus routes. This is going down every lane and side road to deliver to your door. So it's very important to understand that in order to optimize against the customer experience. So they're just three different kinds of transport optimization, where it's looking at all the kinds of data, what you might collect, what you might need to consider, what you might need to measure, and how those measurements can be used to optimize. So from across this transport planning and optimization, you need to look at what happened, why it happened, what could happen, and make recommendations of what we should do. And that aligns with descriptive, diagnostic, predictive, and prescriptive analytics. So Anico provides services across these, and we connect and integrate with the tools that are available, specialized algorithms in each area, as well as the availability of data from those. So I'm going to stop there and maybe pass back to Mike to cover off some closing thoughts and ideas.
Yeah, so, and actually, yeah, I can share the slide again. I was going to say just share that last slide, but I'll just pop that up. There we go. Okay, let's just pop it back up. Thanks a lot, Colin, for that. And it's worth noting to everybody, Colin really did, I'll just go to that same slide. Colin really did skim over that and really took a 20,000-foot view. Each one of those topics that we're heavily involved in today are, they're a whole presentation in their own right for each of those three sectors, be it both public and private. And a lot of it as well is from conversations that we have with yourselves, and we talk about multimodal. I think that really was a great place to meet an awful lot of people in this industry, again, who are faced with these challenges. Again, transport planning is nothing new, but with the wealth of data available to be able to shift and to create, firstly, an advantage for your business, but also to be able to move yourself in the right direction for your business, then it is a new world, and it's a world where it all starts with data. So really coming sort of circling round, I do like to always work in these threes and sort of look at the takeaways, probably what I've always taken away from things when we're putting these webinars together, but hopefully something that you people can take away as well and come back to us and give us feedback. The first one is timely, quality data. It underpins everything. Remember, it was on the left-hand side. It starts with everything when you're doing planning. You must look at the data. And it's also very important to note is when you've got timely quality data and you've worked your way through, you go back. The monitoring, the reporting is what feeds back the loop for the optimization. So it is very important to always report, because that then becomes the source of truth. Have I done the right thing? Have I made the right choice? What's coming out in my KPIs? And then that feeds back, and so the loop is pushed on again. So that was one of the takeaways. Secondly, and it's the topic of this whole thing, is that optimization delivers. We have proven it delivers efficiency, profitability, reliability, and very importantly in today, sustainability that you can report on, that we will need to be reporting on. So it does deliver that. So it's something, if you're looking at that today, if you are a transport planner, look at what we've been talking about today and come and talk to us about what can I do next? Where are my gaps that can take me forward? Because what I'll be able to do, you will be able to tick several boxes, not just the one. And finally, there's no one size fits all. What Colin was talking about today, you'll see all the different areas it touches. Everything it's about you, your business individually, whether it's the TransLink organization across Ireland, or whether it's a private sector transport with 5 trucks, we all have the same challenges and we're all have the same demands placed on us. So when we look at it, we do look at it as an individual. We come, and that's why we always look at something called a data discovery, where we come in and look at particularly what your challenges are, and particularly what data you currently have access to. And also, you don't know what you don't know, is we can deep dive into data, dark data that you didn't even know existed. And we can look at disparate data that can bring and join the dots for that full sort of supply chain type diagnostic approach. So they're the sort of 3 takeaways that I had from it. And that sort of brings us into questions. So we do have a question because it was asked to me earlier. If I'm just looking quickly on the chat, I'll ask this question now on behalf of one of the colleagues here. But otherwise, if you've got a question, would you just pop it into chat and we can take that question. But if we just look at it, this is actually a question column that really came to us from the shows and we're so involved with both TMS and telematics business. In fact, we were just talking to one yesterday again. A lot of the businesses, where do telematics and transport management systems fit in this?
Yeah, well, in short, they're just one part of the many sources of data and the many techniques to optimize those that give a joined up picture. So in everything's instrumented these days. Telematics are everywhere, and we work with and see many what might be seen as competitive telematics systems. Fundamentally, they capture similar sets of data. They will describe their differentiation. But as you've mentioned, Mike, a data discovery kind of confirms just exactly what you're getting. Some of those have increasing amount of specialized analytics that they offer within their platform. But what we see is an organization needs to join that with other data sets. Transport management systems have a very specific purpose, and they allow you to plan at a very operational level and view some of the reporting that I've described in their own tools. And And what we've seen is that companies that are have a transport management system, they're already well down that data digitization journey. But they need to correlate that with others, sometimes even different TMSs for the same customer, or to join up across a supply chain. So, they're maybe for clarity with everyone who's joining and watching here, Anico doesn't offer a product, but we bring those products together. We use best practice tools and cloud services, but it's really the techniques that are unique to the organization. So in our 500 cloud and data projects, they've all had the same delivery methodology, but and somehow deliver the same insights, but they're always bringing data together from different sources, and really deciding how your organization can prioritize where to optimize next, and understand what data is or isn't available to either track or measure or optimize a process. That's part of what we do. So those tools are, for us, a great source of rich, trusted, quality information. And what we end up doing is comparing them with other systems, collating and aggregating, and giving a more strategic view across many processes within a single organization or single supply chain.
Brilliant. I've got a very good question here, and thanks for this question. The question is, I am working on optimizing the movement of empty containers between countries due to demand fluctuations as part of reverse logistics process to minimize costs. What are the main steps I need to take to achieve this cost optimization? I thought it was quite good because, and firstly, I would also say, do please look at our previous webinars as well around moving containers between countries. We had a great guest speaker on talking about one of these particular subjects. But Colin, what steps there to achieve cost optimization on moving containers?
Well, it's a great question. In the first instance, just for everyone's benefit, it's a fact of transport and freight and supply chain that 30-40% of trucks and containers will be empty. So that's an optimization if those could be used more effectively and more efficiently. And I think what Rajav is describing is that there's an unpredictable demand or fluctuations in the demand. So, you can't exactly plan that. I mean, my key statement to this is to look at the data. So what we would do is to look at the information you have, look at those routes, understand the impacts, break the shipping of containers between countries down into their constituent steps if you're going across there, and really to see where there are other where there are opportunities across those for the container to be used for other purposes. So we've seen the emergence in some cases, maybe less so in container empty, but in empty trucks, of kind of sharing of information of when those trucks are empty, such that multiple suppliers can help each other to fill each other's empty loads. I mean, I think, Mike, you have before commented that, when what seems such an obvious requirement in trucks being empty is, haulage firms could fill them, they would, but sometimes it's not economical to do. That's so. Right. Within there, because they have a finite view of their own supply and demand. But when you have a collaboration or you share data with other suppliers, then you can see where there's peak demands in one can offset a shortage of demand in the other. And I guess that's something, sharing freight data is a mechanism that can help identify opportunities to fill on empty freight containers.
Yeah, and very much backhauling, that process of backhauling is one of the biggest challenges. And I think if anyone here or on demand later is joining, I think they'll all nod and agree that that's one of the money pit areas that they try to focus on. But as Colin just said, the reason being that sometimes they're just so tightly bound into a particular direction the truck must go. It's very awkward then. But it was very interesting because one of the events we were at, both myself and David Kerr as well, our COO, we all joined a particular event, and it was very interesting because one of the talks was really addressing this in particular, this backhaul challenge, and they were really looking at the joined up thinking of bringing more and more companies together, so that sort of partnership approach, that bigger view approach to sort of start sharing data with others. And again, that's where people like ourselves come in, because creating that vision board where there's a reporting data structure coming in of all the different empty trucks that are due to be empty, because then you can get your timing, and then pooling all this together. That's what a lot of firms are looking at today, and there are several big companies looking at that. I'll leave the names out for this webinar, but I'd be very happy to talk about those for anyone who wants to contact us around that backhauling challenge, because I think it's a big area where the businesses can really improve their bottom line.
Yeah. One thing to just add into that, Mike earlier mentioned CSRD reporting, so sustainability reporting, and part of that is to introduce, a common standard for sharing data that can be trusted to, say, any company, but transport companies included, how they're achieving their environmental sustainability goals and governance goals. And when they're looking at the freight transport, part of it is to distinguish between empty freight and filled freight. And I think that both the pull of customer and investor demand and the push of the compliance with reporting like CSRD will create a greater availability of data to share on what is empty and full, and that can be an enabler for those kinds of networks and communities that Mike's describing.
Yeah, super. So look, everyone, it probably brings us to an important place. Our next transport webinar, August 28th, we'll publish that on our website, of course, as well. But one of the points I want to bring up is, please let us know what webinar you'd like us to be talking about. And we get all types of guest speakers. So sometimes in summer they're a little bit more difficult to get hold of, but all other times of the year they're great. We can get all sorts of guest speakers on. Particularly, we're doing obviously very heavy around transport at the moment, but we are data engineers first and foremost. So please come back to us and let us know what you would like for us to talk about, and also to, as I say, to get people talking with us all. Please go to our transport blog. You can see the URL there. You can get all the different conversations that are going on around transport, and also reach out to us just to talk to us. We're not always here to try to sell you something. We actually like to learn from you. It helps us move forward. But on that note, I am head of sales. Come and book a data discovery with us. Let us show you what you're not seeing in the data to actually move your business forward. Give us that opportunity to do that. And to do that, all you need to do is contact either myself, mike.o'boyle@aneco.com, or of course here today, colin.hayden@aneco.com, or just sales@aneco.com, just generically to reach out to us. But please do reach out to us. We're human. We like to talk, and we like to get your feedback. So on that note, Colin, thank you very much for all the insights in transport and how to optimize for transport planning. And thank you everyone for joining. Hopefully you've all grabbed your lunch or something like that in the time, and look forward to seeing you all at our next webinar. So